Okay, so this is an overview of several different methods of sampling. Ideally, we get what is called a random sample. And in a random sample, each person in a population, so each member of the population has an equal chance of being chosen. Okay, so this is a bit tricky. So what we could do here, and to kind of illustrate a point, is we could say there are 1, 2, 3, 4, 5, 6 members of a population, and I want to select 2. Okay, so what I could do is I could put all 6 names in a hat and pull out 2. Right? That would get me a random sample. So if I put all 6 names in a hat and pull out 2, then each member has an equal chance of being chosen. All of them have 2 out of 6 chances of being chosen, which is 1/3. Okay, so that's there. But I could also get a random sample by saying I'm going to put 3 slips of paper in the hat. I'm going to put number 1 and 2 on one slip, 3 and 4 on another slip, 5 and 6 on another slip, and I have chosen one of the 3 slips. Now, I've still selected 2 names. I still have gotten a probability of 1/3 for each individual person. So this is still a random sample. Okay, so this is 2 different ways of taking a sample that both get me a random sample. So this is a bit of something that I want to dive a little bit into. There is something that's even more superior than a random sample, which is what we're going to call a simple random sample, and we'll take a look at that next. Okay, so a random sample has each member of the population having an equal probability of being selected. A simple random sample sometimes called an SRS, is a little bit different. Now, not just each member, but each sample of size n, of a particular size, has the same probability of being chosen. Okay, this is a little bit different and a little bit more difficult to achieve. Now, if I had taken my 6 names and put them into a hat and chose out 2 names, they'd each have a probability of 1/3, each name being chosen. Now, if I take a look at this and I say, well, can any pair be chosen? Can I pick 1 and 3? Can I pick 2 and 4? Can I pick 1 and 5? Sure. And what is the probability of that happening, right? So how many pairs are there? Well, 1 can be paired with 5 different numbers. 2 then can be paired with 4 different numbers that aren't 1. 3 with 3 different numbers. 4 with 2. And 5 with 1. So that's 5 plus 4 is 9. Plus 3 is 12, plus 2 is 14, plus 1 is 15. So there is 15 different ways that you could pick a pair out of this. Well, each of those 15 pairs has one chance of being chosen, so each pair of 2 has a 1 in 15 chance of being chosen. Now, if I had done the game where I put on slips of paper 1 and 2, 3 and 4, 5 and 6, well, and then chose out one slip, each individual has a 1 in 3 chance of being chosen. Now, the pair 1 and 2 has a 1 in 3 chance of being chosen. Same with the pair 3 and 4, and the same with pair 5 and 6. But the pair 1 and 5 cannot be chosen. So that would be 0 out of 3. So in that case, the 1 and 5, because they're not on the same slip of paper, I'm only picking out one slip of paper. So the 1 and 5 can't be chosen together. Neither can the 2 and the 5, neither can the 2 and the 3, the 1 and the 4. These all come out as 0. These probabilities are not the same. Picking 3, 4 has a 1 in 3 chance of being chosen. Picking 4 and 6 has a 0%. So these are both samples of size 2, but they don't have the same probability of being chosen. So this method is a simple random sample. This one is not. Both are random, only this one is a simple random sample. In fact, if you're doing a simple random sample, it can always be boiled down to putting all the items in a hat and picking them out individually. If you're doing anything else, you're not going to have a simple random sample. Now, why do we go after this with a simple random sample? Because simple random sample quite frankly, is the gold standard. It is the best, best possible way to achieve a non-biased sample of the population. But it's very difficult to get when the population is large. So if it's a large population, this makes it very difficult to take a simple random sample. It's very hard to put the names of all US citizens into a bucket and then pull out a random selection of them. This would be an extremely difficult thing to do. So we have to have other sampling methods. A commonly used sampling method is what is called a systematic sample. And with a systematic sample, basically you make a list. 1, 2, 3, 4, 5, 6, 100, whatever, of the entire population. And then you say, I'm going to start somewhere on this list. I'm going to start with item number 2. And then I am going to pick every so many people on the list. So I might pick the second person. I might pick 3 more down the road. So that would be the 5th person. 3 more down the road is the 8th person. And then I just keep going until I exhaust the list. So I'm going to pick every single person on the list by jumping by 3. Okay, that would be a systematic sample. Now, upside is this is random. Okay, each person on that list, so long as I choose the first one at random, has an equal probability of being chosen. It's not a simple random sample because I can't pick 2, 3, and 4. That's not going to happen. But because I'm only allowing myself to pick every third person. So I get random, but not SRS with this not SRO, SRS with this situation. Okay, so systematic, you pick a starting point, and then you just keep jumping by the same number. Okay, another popular way of sampling is what's called a convenience sample. And that is you just survey parts of the population that are easy to survey. This is literally walking into Alumni Hall and finding the first 10 people you can and giving them the survey. So this is a sample that's completely out of convenience. There's no sense of random. There's no simple random sample. But the upside is it's easy. Okay? It's not very valid, and it's highly likely to result in biased results, but it's just simply easy. So convenience samples, this is like people at the mall with clipboards. They walk up to you saying, do you want to take a survey? They're hitting people who've got some extra time and are bored, and they're willing to do the survey. Not a very reliable way of sampling, but it is done. Okay, another thing that's tried sometimes is what is called a stratified sample. And this is oftentimes confused with the next type of sample we're going to look at, which is called a cluster sample. In a stratified sample, you have a population. Let's say I have a population of 25 people, and you break those into subgroups. And then of those subgroups, I sample a certain portion of each subgroup. So I might say, let's grab 3 from each subgroup at random. Now that will get me a fairly representative sample. I may have issues with how I create the subgroups, things like that, but this gets me a fairly representative sample. Now, this would be an example also where I have a random sample because each member has an equal probability of being chosen, but I don't have a simple random sample. Okay, so there are groups that just cannot be chosen because like a group that would have every member of a subgroup can't be chosen. So this is definitely not SRS, but it does achieve random. So that is a stratified sample. So the key here is that you are picking parts of subgroups, parts of all subgroups. Okay, last group I'm working with here is what is called a cluster sample. Okay, in a cluster sample, again, you're taking parts of the population. You're taking the whole population. So here is the whole population. So we're going to create 25 people again. And this time you're going to break them into subgroups again. And then we're going to randomly select subgroups. So we might take this one, and this one, and we're going to sample everyone that are in that subgroup. So here you are taking all of some subgroups. We call those subgroups clusters. Okay, so you're taking all of some subgroups. So this is different from the stratified sample where you are taking some of all the groups. Here you're taking all of some of the groups. So that's the difference between cluster and stratified. Okay, so again, each person has a chance of randomly being selected. This is an example of random sampling. But again, there are certain groups that can't happen. Like you can't pick somebody from each of the groups. So this is what keeps it from being SRS. So it is random, but it is not a simple random. Okay, so for sampling methods, we have made a distinction between random, where each member has an equal probability of being chosen, versus simple random sample, where each subgroup has an equal probability of being chosen. We've looked at some sampling methods that are not just simply taking a simple random sample, because they're very difficult to do, especially with large populations. We've done systematic sampling, which is taking like every third or every fourth person from a list. We've looked at convenience sampling, which is just like grabbing the easiest people you can to sample. We looked at stratified sampling, which is taking part of each subgroup. And we've looked at clustered sampling, which is taking all of some subgroups. None of these four are SRS. Systematic, stratified, and clustered sampling can be random, but cannot be simple random. All right, so there's sampling methods.